Alright, in the first part, we talk about some of the X800 standard for security, and we explain this diagram. We explain what's the security attack, and we classify it into two types. We have a passive attack and we have an active attack, and we said the passive attack will not affect the system, will not do any change to the system, and it's really hard to detect and to prevent. But we can face the passive attack by doing some encryption. The active attack actually is the opposite of the passive attacks, an attack that involve modification of the data or affect the system resources, the hardware or the software. We discuss some common types on passive attack like traffic analysis, eavesdropping, sniffing, and snooping. We said it's very difficult to detect, and the only way to try to prevent this by doing some encryption. The active attack is the opposite, and we have some example on it. Like it's all about changing the system, like making the resources unavailable, doing DOS or modify the message or try to capture the data or even try to pretend to be someone else. It's the opposite of the passive attack. It's quite difficult to prevent, okay, not detect. We can detect it, but it's quite difficult to prevent active attack because it does a potential harm to you, like a physical or in the software or the network, because even if you have vulnerability in anywhere in the system, the active attack will happen there. So you need to assess your system, see where is the weakness in the system, and try to block this weakness and remove it from your system. You will not get any attacks. That's what the company actually do, and probably you'll learn this in another course. Now, the security service is the third focus on the X800 standards. The security service is a process. We said it's a process or communication service that provided by the system to give a specific kind of protection to a system resource. So it's a special purpose security system for something. Now, one of these things is called authentication. For example, authentication is to make sure that the person is the same person he claimed to be. So if I say I'm Dr. Munder, for example, the system will check exactly if I am Dr. Munder or not. So that's the authentication. All right. The access control, and we said that each user has a level of access. Okay. So if you have an access control that prevent an authorized user of some resources. So you have, even if you have access to the system, you are authorized, you still have access control to some level, not the whole system. Data confidentiality, we're talking about confidentiality by hiding the data or protecting it from unauthorized people or unauthorized user or unauthorized disclosure. Data integrity is to make sure the data is not changed and accurate. So when you send a message, you make sure this message is not changed or unchanged during the transmission, where if it's changed, then someone is doing some attack or active attack. Now we can do this by a different way. We will give you an example later by doing digital signature or hashing algorithm. We'll talk about this later in the course. The last one is called non-repudiation, which is basically, we said that someone might somehow uh, block one of the resources of the system. So non-repudiation, protection against denial by one of the parties in the communication. If someone tries to block one of these services for the system, now non-repudiation is try to prevent this from happening or protecting from denial of services. Try to make sure that all the services are available. All right. Now this is the security mechanism. All right. Now the security mechanism basically define uh, as a process for security mechanism. All right. So yeah, you need to know which one you want to use based on the attack, so you can go to the security mechanism. So the security mechanism defined as the process that designed to detect, prevent, and recover from security attack. The mechanism is divided into two types. right? Some of this mechanism is for a specific protocol layer, such as TCP or the application layer. Some of these mechanisms are not for a specific layer, it's for all the layers. All right, so just simple two type, for a specific layer or for not non-specific layer mechanism. One of the specific security mechanism, for example, encipherment, which is basically we use mathematical algorithm in order to make the data in different forms. So it's not readily intelligible. So data into a form that's not readily intelligible, so no one can read it. So we use mathematical operation. It's similar to encryption. We have the digital signature, which is basically similar to the physical signature. It is just, when you send a message to your friend, you sign this in digital way, so your friend know exactly that you sent the message. So basically, data append to or cryptographic transformation of the data unit that allow recipient of the data to prove what? Prove the source and integrity of the message. If someone tried to pretend you and send a message to your friend, your friend will discover that because the signature is different. It's similar to the physical signature. Somehow, if someone trying to fake it, it's hard to fake it because some maybe you can fake the physical signature, but digital signature is not easy to fake. We will see why is that. The access control is one of the specific mechanism, security mechanism. Basically, is enforce access right. Who has to do this, and who has uh, right not to do this. All right. So when you look on the system, you can do something, but you cannot do other things. Only the system administrator probably can do everything in the system, but the users, they have specific tasks to do, to perform in the system, which is basically not similar to all of them. So they have different tasks. Now these are some of the specific security mechanism. Also, we have other specific security mechanisms such as authentication exchange. Okay, uh, to make sure that you are the right person, send the message. So ensure the ensure the identity of an entity by means of information exchange. Traffic padding is if you have a message and there's a space or gap between the message in the data, there's a space between the data. So what traffic padding do is insert bits in the gaps or insert data into these spaces. All right. So when someone trying to translate the message, even if it's encrypted or not, he will not exactly know it which one is the word, separate the word from the non-word, a sentence and something like that. So he will see it as a continuous word. That's one of the things that we can somehow trying to do it by to prevent like cryptanalysis. Talk about cryptanalysis later on. We have a routing control. An example of physical example of how to control, if you want to go to Muscat, for example, you have different way to go. So the routing control is specify the route for the message to go based on security issues. All right. So which is the safest and which is the securest way or the route to Muscat, for example, you go. Now the same thing happen in computer. It is select, somehow physical secure, all right, route for the data to be transmitted from one computer to another computer. Now this route is chosen based on some suspicious of unsecure things. So if someone has an unsecure route, has no firewall, no antivirus, the system will not go through that route because it's unsecure. It will choose another secure route somehow. Neutralization is all about trust someone. Okay, they use trust third party to secure certain propriety and exchange. For example, we trust Microsoft. We save the data on Microsoft account. So if something coming from Microsoft, then we say it is secure. We trust this because it's a well-known company. But if you get an email from, we always get an email, and if we look at the email, you see it's not from Microsoft, then it's claimed to be from Microsoft, then we don't trust this. We only trust that third party to, somehow make sure that our data is secure, like Google, Microsoft, Amazon, or something like that, or the cloud services now. This is a very important table that shows exactly the relationship between mechanism and services. Okay, so the mechanism will use some of the services. For example, peer entity authentication used three mechanisms. Okay, use enforcement, use digital signature, and use what? Authentication exchange. For example, another example, data integrity used three mechanisms: encipherment, digital signature, what? Data integrity. So these are an example. You need to know the service mapped to which mechanism. This is, each service is mapping to maximum three mechanisms. Maximum three mechanisms. You see, access control is mapped only to access control. So that's easy one. All right. You can see confidentiality is mapping to what? To how to make this data or hide this data by doing some encryption and by choosing what? A secure route. So these two, it's just not memorization, it's more like understanding the mapping between the service and the mechanism. If you know what's the mechanism and you know what's the service, you can map between them, which one need the other one. All right. Now, let's talk about the main topic in our course, which is basically cryptography. Now, when you talk about cryptography, we have to know the word encryption. All right. Encryption means what? Encryption means encoding. So if you have uh, a cat, for example, and you want to encode this, you could do it in a different way. You could make it like this, encode it in this way. So this means, for example, cat. All right, this is encoding, changing from letter readable sentence to unreadable sentence. All right, now it's basically, the definition is the process of encoding a message or information in such a way that only authorized parties can see it or access it. This is, for example, a computer A, and this is computer B. Computer A want to send data to computer B. All right, you can see the data here. They have to use the internet in order what? In order to transmit this data between them. They have to use the network or the big network, which is the internet. If you try to write the data, you need to have what? You need to have a firewall and encryption. All right. Now, the encryption will change the data from readable format to unreadable format. This is the format. Now you can understand this. This is data. Very simple word. Data. Okay, this is data. If you look at this, can you read this? It is not data. It's just a symbols, and doesn't mean anything. So if someone in the internet try to get this information, even if he get the information, he will not be able to, know the content of the message, because it's what? It is encrypted, right? Now, when it comes to the computer B, they have decryption. Okay, he's the only one who can decrypt this information. The decryption, he has a key. All right, when this guy encrypt the message, the other B know exactly the key, so it comes as a symbol. He decrypt it, and it comes as the same word, data. So B can only read the data. In this way, even if the channel is not secure, we try to keep the confidentiality of the data. So if someone saw the message, he will not be able to understand the content of the message because it's encrypted. All right. Yeah, the people used to speak in an encrypted way before that. It is just now. Why do we need to encrypt the message? This is a very good question. Because we transfer the message over the internet, and there's a lot of users here. There's a lot of people can see this message. If this message related to the government, related to the military, related to the financial uh, organization, the educational or something, this is sensitive information, okay? So we need to decrypt it. So because a lot of people are here using the internet, all right, this information need to be encrypted, so these people will not be able to understand this message. If they get it, they will not know the content of the message. So it's very important, because we transmit information over the internet, we need to encrypt it, and government need it, financial institute need it, and everyone need it, okay? Even a private user, they need it, okay? You send information between your browser and the server somewhere. You need a password, you need probably you enter the password, or you enter your credit card number, or you enter your birth date, or you enter your private photos submitted, something like that. So it's all sensitive information, need to be encrypted, because a lot of people are using the internet and they can see that, right? Believe me, everything on the internet can be reachable. If it's not encrypted, people can see it. So try to use encryption all the time. This slide is to explain what we said in the diagram. So have a look at that. Now let's know about we know what's the meaning of encryption and why we need encryption. Now, what is encryption exactly? We know the meaning. Okay, where does it come from? Right? Encryptions, actually, let's look at some of the terms, and then we know where encryption comes from. So these three terms: cryptography, cryptanalysis, cryptology. Let's start from what? Start from cryptology. Okay, start from cryptology. This one here. Cryptology is a branch of what? Mathematics, applied mathematics. Okay, encompassing by cryptography and cryptanalysis. All right, so it is contain both cryptanalysis and cryptography. So it's actually applied mathematics that combine cryptography and crypto analysis together. All right, it compose both cryptography and cryptanalysis, because they both use mathematics. All right. Now, cryptography is the art and science. You see, the same thing as cryptanalysis, the art and science. Okay, but when you say cryptography, keeping message secure. Okay, it is practiced by what? Cryptographers. We call the people who study the cryptography are cryptographers. Now, for the cryptanalysis, it's the same, the art and science of, but what? Recovering the plain text is the opposite of cryptography. Okay, from the encrypted message. When you do the cryptography, okay, cryptography, you encrypt the message. Now, cryptanalysis, analysis, try to what? Try to decrypt the message. Try to get the message. Okay, try to recover the message. What is the message comes from here? Trying to see what is exactly the message, so they're the opposite of each other. They are both art of science. They both, one of them is keep the message secure, and the other one try to recover the text from the encrypted message. So if you want to know the meaning of cryptography, basically it means what? Comes from crypto, which means hidden, and graphin means to write. So write to hide means, okay? So this is comes from cryptography. All right, the cryptography. Now, if you wanna send A is a sender and B want to receive the message. So A has a text, we call it plain text. This is the component of Cryptosystem, component of the Cryptosystem. Remember this, component of the Cryptosystem. First we have the plain text, you write your message, and then you give it to the encryption algorithm. Encryption algorithm will use what? Will use key. What do you use? Key. This is a key, right? Use a key to encrypt the message, right? We'll use a key to encrypt the message. So this is the second part, which is the key. You need a key, all right? The key could be a word or any symbol that you agree on. You're gonna use the same key of the receiver, and this is encryption algorithm. Okay, algorithm. We have many encryption algorithms. This is the third part. What do we get? We get the ciphertext. The ciphertext is encryption, encrypted text. Encrypted text. This is the output from encryption algorithm. So you give the plain text to the encryption algorithm and the key, and you will get the ciphertext. This ciphertext is, no one can read it except the one who has the key, which is B. Now we'll send the message over the network, will come up as a ciphertext, will come to the decryption. Decryption, this person knows the key. This is exactly the key here. Okay, we'll give it to the algorithm, which is decryption algorithm. He will get the same plain text and be able to read the text message. Anyone here in the internet will not be able to read the message. This is the component of a cryptosystem: plain text, encryption algorithm, key, and ciphertext. Right? And I already mentioned them all. So the crypto system component are the plain text, which basically a message. You can read it. All right. This message could be a text. This message could be a picture, a map, or anything. Ciphertext is the encrypted message. We call it C. Ciphertext. Cryptography algorithm is the algorithm which is basically a mathematical function used to convert the text into what? Into ciphertext. And the key is the way that we use to convert the algorithm. Okay, we call it K. So if you wanna more explanation, let's say it here. We do the encryption. This is called the E for encryption, and we give the key. Okay, so the message will go into the encryption algorithm, and also using the key, it will produce what? The ciphertext. The opposite way is the decryption, okay, which is the ciphertext will go into the decryption algorithm. Decryption algorithm will use the key to produce what? AMP. So it should be the same AMP. This is a mathematical function, and it's depicted here in the diagram. All right, the same. I draw it in here. So it's a very simple way to understand that. Now, if Alice want to send a message, you need encryption algorithm, you need the key, you need the message. So put them this here in the encryption algorithm, it will become ciphertext. Anyone here cannot see it, like Evie, Mallory, and everyone here will not be able to understand the message. When the message comes to the other end, it will go to Bob. He will decrypt it using the key. He will get the message. Okay, this is a very simple. So if even active attacker or passive attacker in the middle here will not be able to. So passive attacker will not be able to read the message to understand it. Active attacker will not be able to change the message because it's somehow encrypted. Even if he change it, they will discover it. Now the passive attacker and the active attacker, the message is encrypted here. They try to do a cryptanalysis. They try to do what? Analysis. Now they cannot read the message, but what they try to do is try to see something in the message. So try to analyze the message and discover the content of the message using analysis. So basically they study the message in order to get some hidden aspect of the system. Okay, it's a way to breach cryptography. All right, it's a way to breach the content or get the encrypted message. So somehow, if the encrypted message contain, for example, C C and contain here C C, they try to analyze, for example, how many times the C letters comes, like 6 times. Letter A comes 4 times. Doing some analysis, trying to figure out the words. Okay, we'll not study cryptanalysis. I'll just give you an. Now, cryptanalysis can be done in two approaches. Crypto attack, which is basically they have an algorithm that analyze the text and see if they can get the key right from the text. If they get the key, then they can decrypt the message and see the text, right, which is take a long time. It depends on how strong is the algorithm is. Some algorithms are very weak, others algorithms are very strong. We'll study this algorithm. Brute force is basically trying every possible key, all right, and decrypt this. So the key could be a date of birth, could be a name of the person. They try everything about these two parties, trying to discover the key. The brute force is trying all possible attack, all possible keys on the ciphertext in order to get the plain text. But the cryptanalysis attack is they have an algorithm that analyze the text and try to figure out the key instead of uh, all these things will not work because it depends on the how strong is the algorithm. If it's an easy algorithm, they can break it easy. If it's not, then they can do it in 2 years, which is a long way, and the information will become old. Now, the last thing we want to distinguish between stenography and cryptography. Stenography is hiding the information inside a picture. If you want to send information to your friend, you send a picture, you take a picture and put the message inside the picture and send it as a picture. People will see that you send a picture, not a message, and your friend will take the message and extract the take the image and extract the message from it. But this is called stenography. There is no encryption at all. You just put the message inside the picture. You hide the message inside the picture. All right. Cryptography, no. Cryptography is different. Cryptography is making the message unreadable. So this is the difference between cryptography and stenography. You can try, stenography. Try to visit this website and provide an image, write a message, and the website will put the message inside the picture and send it to your friend. Your friend will do the same, give the picture to the website, and he will get the message from the picture. So it's not encryption, it's just hiding the message inside the picture. This is a review question for you. I hope you summarize everything we do, difference between different cryptography in real life, component of the crypto system, difference between active and passive attack. We look at differentiate between security service and security mechanism, and also define what's crypto system and its component, and we talk about some scenario, and also what's the difference between cryptography and stenography. If you have any question, you can just email me anytime. Thank you very much and have a good day.